Right, okay, everybody. Lightning. I found this deeply fascinating. Introduce you to Steve Mobbs. Colleague Nick Cook is online. I first came across something at SeaWorld, which I'm sure you know what many people have been to years ago. I was walking down the aisle. Suddenly to the right, there was all these things flashing on the screen. Lightning flashes going on live around the world. I was really into it, fascinating. Just how we kind of didn't meet you there, but I met your colleague, another Steve. Um, so without further ado,
Yeah.
I'll introduce you and
Thank you very much. Steve from TMS. The whole lightning thing is quite fascinating, and as a result, we ended up getting more and more involved with this as things have developed. Now, firstly, I'll step back and thank you all for having me here. Appreciate that,
well,
the opportunity.
Yeah.
No, great. So anyway, my name's Steve. I get involved with a lot of the technical solutions within Technical Marine Supplies. I deal with a lot of the boat builders throughout Europe, specifically on the lightning systems, from specification through to implementation and getting the right partners to actually implement the solutions and the associated certification that goes with it. I'll move on here, and we can see exactly why I'm here specifically to address you guys. This is, yeah, that's not.
All right. Okay.
There we go. Right. Okay. Lightning. Right. The aim of this little chat, light-hearted chat, but it's to actually kind of give you a little bit more an understanding as to the cause, effect, and some of the protective solutions that are available for lightning systems today. Some figures that are out there. Now, this was based on insurance figures from last year, from 2023. Okay, and we've got some backup information if anybody's interested. 1.4 billion lightning strikes across the world each year, apparently. Okay, that's what the average generally tends to see. And we can back some of this other stuff by data. Insurance figures from 2023 indicate that 3 in 1,000 boats were struck, okay, throughout last year, which is a fair percentage. 13 people died from lightning strikes in 2023. And recently, insurance companies have really started to kind of pay attention to the opportunities and also solutions that are available out there. Okay, further research that was actually done in the University of Washington and incorporated with NASA actually showed here maps of parts of the world that were more prevalent to lightning strikes. Now, we all know the popular areas, the old tornado valleys and all this business, and certain areas of the Mediterranean, areas of the Far East, and certainly around the Florida and Caribbean area. Okay. From that research, it was shown that also the types of boats are quite important. Funny enough, 6.9 out of 1,000 were multi-hull sailboats. I mean, we do see this hugely in a leisure environment, just how many boats, catamarans specifically, are being struck by lightning. It's incredible, really, just what the difference actually it does make. And we do an awful lot of business with the catamaran manufacturers through France specifically to help protect and the catamarans as such. These things are obviously also loaded with leisure electronics, which are very vulnerable to the effects of lightning strike and the nature of the vessels that are hit, whether or not it's kind of ruptured or split carbon masts or damaged aluminium masts, going right the way down through to hull integrity and such like. And you can see here as they kind of go down in the different categories, right down to your little runabout, which is very unlikely to be hit by lightning, or certainly have a direct strike. Okay. One of the things that this always kind of brings up when we start talking about this is that generally, I hope you don't prove me wrong here, but you might do, but I think we all generally know somebody that's had or been involved with a lightning strike of some description. whether or not it's on a working boat, dredger, crew transfer vessels on the commercial side, cruise ships, tankers, certainly on the leisure yachts, catamarans, as we said, but also super yachts and the large sailing yachts as well. That do seem to, some of them seem to get struck for fun almost. It's quite a scary thing. There is an element of that, but as what we'll see with regards to some of the reasons as to why lightning actually strikes, it's a build-up of ionization within the atmosphere, and sometimes things like solar panels and things like that. Even though it's, I wouldn't want to scientifically state that in any kind of kind of published paper, but the increased ionization effect does actually affect the build-up of static within the atmosphere, which can help encourage the conditions that would help lightning. But I mean, also, the whole catamaran thing doesn't necessarily really make sense scientifically like that. It's not like it. You looked at the figures earlier, and you think, right, okay, well, it's got 2 holes in the water, got 1 mast sticking up. Quite often they're bigger because of the size, but it doesn't always run through.
Using catamaran,
Of course, there is always that situation. Yeah, but it's not just the case. It just does seem that these guys are, and you're quite right to that degree, because also the popularity of catamarans has gone through the roof in the last 10 years. So there's an awful lot more out there to kind of maybe weigh the balance, and the survey hasn't really been done. All we seem to know is that maybe it's also the measure of the fact that the guys that have got catamarans on board, maybe they've got the money to actually put these systems on and start looking at, kind of, they say where they're going to be going, and, the comfort, because a lot of these, there's a lot more liverboards as well now that use catamarans, which is, a huge factor, because they're there on it all the time, through all times of the year, and not just bobbing in for the odd week or two to kind of take it out when the weather's nice. So there is that to consider as well. Okay, now this is quite interesting. Now we were saying about regions, all right, and this is going to work into something that we're going to move on to in a second as we start touching on the workboat 3 scenarios. All right. Now there's a website which was referred to just now, called Blitzortung. Okay, we'll try and link into it in a bit on some further slides, because this does actually show you live lightning that's happening around the world at any time, which is really quite interesting. I mean, if this was a sales presentation, it could actually be commercial suicide, because trying to do something like this is trying to rely on animals or small children to do something you want, because you can almost guarantee there probably won't be any lightning anywhere when we try and actually pull it up and have a look. Doesn't matter. This is a technical kind of talk, so that's fine. But this was a sample that I used for one of the workboat manufacturers in Wales to actually show on the back of the Workboat 3 legislation that people think and have this assumption that we don't get lightning here. All right, this here was just from a 12-hour period. It's just speeded up a touch. Okay, don't know if I've got any volume on this, if it will actually. There we go. All little spots and spikes. These are lightning strikes happening over a 12-hour period, and you look where they are. That's just in 12 hours. Okay, and how the website actually works, they've got a bunch of EMP, electromagnetic pulse receptors all over the world, and they triangulate. So basically what it does, it can pick up any EMPs within the atmosphere, and there's a base of triangulation. It can actually pinpoint where those strikes will have happened. All right, so it's interesting, but that just goes to show that within the UK we still get lightning strikes. It's not just the Caribbean that cops it. Okay, we'll see some more information on this in a second. All right, because this is one of the reasons that I'm here to actually talk to you about. The whole Workboat 3 and this particular code. Whoops, hang on, let me went too far there. Which is this clause here, lightning protection. Now, Rob didn't mention kind of touch on this particular change or amendment, but it's really quite important for those who want to kind of consider it. Now, the difference is that Workboat 2, it was a recommendation, okay, and it was purely that. Now it is actually a rule, okay, so it does actually fall into the statutory requirements. Now, the thing about this, though, is it's a big rule that you could effectively get out of if you really wanted to, because at the end of the day, it does actually state where a considerable risk of lightning strike is identified. So, you know, you might sit there and think, well, actually, there's no lightning here anyway, you know, so it's not really a risk area. So therefore, we're mitigated from the whole situation and we don't have to worry. But as professionals, it's our kind of duty to effectively make sure we're doing the right thing and advise the customers and the relevant people what is actually happening there. This is again why I'm here, to kind of try and empower you with a little bit more information as to what you can do and what can be recommended to customers, that want to adhere to this. Now, we noticed that on that little clip for 12 hours, right, there was quite a lot around the southeast. Now, I would have thought that basically maybe you'd get more lightning up in Scotland, maybe. I don't know. I mean, you'd think possibly a bit more weather and all this kind of stuff. Now, you'll notice here, it's actually not the case, right? Now, this is data that's been collected over a 10-year period by Toro, and this actually, and the Met Office, and this shows the average number of days with lightning, okay, per year, right? And that's lightning days. In terms of the amount of lightning strikes, okay, it says it can actually have between 10,000 and 50,000 strikes per lightning day, right? Now, this is per average. Now, if you can see that, it's a little bit, you might be a bit far away there, but you'll notice 15 to 19 days of the year can have up to 50,000 lightning strikes per day within that southeast region, right? Up here, it's half that. So it's hard to actually gauge where you're actually sitting with this, and you can't necessarily use preconceptions as to whether or not you think we're going to get hit by just that, because there is data available that does actually show you that no matter where you are, it's right up here, that there is a chance that you could get hit. Now, one of the things that we want to look at further now is how it affects you guys. All right, now this is what we're going to talk about now. The next bit is what type of technology to recommend if your customer feels that, or if you feel that you actually need to make a recommendation. All right, does any existing system comply with the new legislation? All right, that might have something on already. And is the vessel grounding adequate? It's great having a supposed system there that looks like it's doing the job, but is it actually doing what it's meant to be doing? And where is the vessel operating? Last one, operating conditions and crew safety as well. All right, so there's just some brief considerations. We're gonna run through these and have a little chat on each one of them. Okay, so what type of technology to recommend? There's a few different types around. There has been, from the base of Franklin back in the early days, his initial proposal of a Franklin rod was what was a lot of people still use it today. It's your standard like lightning conductor, spiky thing that sticks up. And the whole idea of this is to actually attract lightning, and then once it's been attracted, channel it away somewhere safe. Okay, that's the whole plan behind the Franklin rod theory. We'll look into these in a little bit more depth as we go through the presentation, okay? You've got a static dissipator. Some of you see like the familiar toilet brush on the top of masts and such like this. I don't know if you've seen them. Basically what you have there is like a hedgehog on top of a stick, right, which basically through its static dissipation supposedly takes the charges that are within the atmosphere and splits them into smaller bits, basically. All right, but it still enables the discharge to actually happen. All right, so that's what the static dissipator is. Okay, you've got surge protection, thermal fuses. If a device ever has anything like this, it probably means that it's not working properly, because at the end of the day, if a true lightning protection or prevention device, it means that you don't need anything like this. Okay, it just means that there are systems out there on the marketplace that fundamentally they're designed for buildings. Okay, so once you get over a 3-degree heel, then they potentially expose a target area for the lightning to strike on the vessel. These have been used on land for some time, but some companies in that have been trying to use them at sea, and there has been issues. Hence why they generally protect themselves with having surge protection and thermal fuses as well. All right, so that's again something else to kind of keep an eye on or look out for. Or you've got the CMCE technology, which is the technology that we specialize in. So I'm not here to try and sell this, but I will explain the technology as to how it actually works and the difference in what actually goes on within it, because it's really quite a fascinating way of dealing with the threat of lightning. Okay, so does any system exist on the vessel? If there's anything that represents a lightning system on the vessel, well, it'll comply because that's all it basically says. It says that you have to have, we recommend you put a system on there or whatever. We want you to have a system if it's very, very woolly, as we've just seen. All right. So basically, if there is a system on there, then in theory, it could comply. However, whether or not we're doing due justice and diligence, that's another issue. Okay. Because is it good enough and fit for purpose? All right. So again, it needs to work, not just represent something to really tick a box. And the final point of that is, yes, being compliant is a very long way from being safe. All right, because there's an awful lot going on within a lightning strike when a vessel gets hit that can have all sorts of repercussions. All right. Okay, is the vessel grounding adequate? Now, things that we see here, assuming it's got a system on, you've got to consider the grounding path and the cables. Now, some will have whopping great big straps on them. Some will have thick cable. Many won't have anything at all. All right, so it's a case of having a look at this and thinking, right, okay, what is the system designed to do? If it's designed to take a hit, then we've got to realize that you're talking something in excess of 20,000 volts maybe, and maybe 30,000 amps that this will have to deal with. Yeah, so it's quite a considerable amount of electricity that is being expected to actually kind of channel away safely without causing any damage to either property, electronics, or people as such. Okay, so you've got straps and also the earthing plates that associates it to. There's no point having all the straps in the world in an earthing system if it's, if the hole's completely painted and it can't go anywhere. So again, that's something to consider, and the state of those earthing plates as well. If some people see them and paint over them, they get covered over very quickly with muck. So you have to make sure that they are being effectively used. So that's when you look at earthing plates, there's many available on the market. You get all sorts of sintered and various kind of channel flow earthing plates and grounding plates that are available now, not just your general sacrificial anodes used as well, to maximize the surface area that's actually submerged to help dissipate any charges coming through there. Additional things connected to earthing systems. So lots of things are connected. Everything's earthed effectively throughout the electrical system. That can have effects, obviously, if it's having to deal with a massive amount of electricity coming down the conductive line, right? Because this will get fed back again as well. Okay. Okay, where is a vessel operating? We've had a little look at that, but one of the things is it going to stay there? boats move. That's obviously what they do. So, you know, and whilst they might be commissioned and working for in one particular area, if you're talking about a workboat that's doing certain things, there's a good chance it will be staying there for a while, but it doesn't mean to say it will do. And it doesn't mean to say the conditions are going to remain stable either. So you're not always going to necessarily be, you know, be safe, because like we saw just now, it's not just the Caribbean that has lightning. And you might find in your head there might be something that's operating in the north of the country that's in a lesser, you know, dangerous area, and then it moves down to Dogger Bank or something like that, where all of a sudden it kind of starts getting into that lightning strong area that we do actually still have. Okay. Okay, operating conditions and crew safety. Crew transfer vessels these days, as they're becoming more and more robust, are operating in more and more harsh conditions. There's a, you know, the actual reasons for now stopping boats going out have become less and less. And, you know, if they're sailing in the harsher, stormier conditions, they're going to be putting themselves more and more at risk of lightning. It's simple, you know, so it's, now, and we all have duty of care now, a lot more so than maybe we used to. Okay, in terms of the operating time, if a vessel gets hit, will it remain operational, and what damage is going to occur? I mean, certainly with the move in certain areas to electric propulsion, and if the electric boat gets hit, it's completely fried and dead in the water. So it's certainly not operational. And that puts everything, you know, everything and everyone at risk. You know, because as like I just said, it's not just the actual risk of shock to, you know, the crew on board, but also the impact that it could have on everything else that's involved around that. And the other thing is, it's interesting, is that lightning doesn't always show straight away. It very rarely does, actually, apart from the actual immediate impacts that you get, and you can see straight away if things are blown. You know, that goes right down to damage on the engines, because the amount of electrical components you have now in an engine, you know, they can be toast as well. You know, and you know, if you've got an engine that doesn't work and you've got maybe other backups that don't work, again, it means you're effectively dead in the water until, you know, such times as something else can come along and help. You know, so it really has become a little bit more, you know, our reliance on some of the modern engines and equipment that actually operates all of that stuff, fly-by-wire control systems and all this business. All of this puts us at a bigger risk than we were decades ago, when things were a lot more manual. Where, you know, if your engine, you know, something like that wouldn't affect your engine at all. You know, you could always make sure that you could jury rig something to start and make it go. Whereas now there's no guarantee you can actually do that. So it's becoming more and more important to make sure that things are protected, because the technology does actually exist. Before we look at the actual technology behind what I'd like to talk about, we're going to have a look at the actual formation and the interesting stuff as to why lightning happens. Okay, 300 million volts and 30,000 amps. Okay, travels in excess of 20,000 miles an hour. The thunder that you hear is as a result of superheated air exploding. It's an interesting one. And a lightning strike creates an EMP. We know, I think most of us will know this anyway. Okay, so that's kind of some interesting figures. Okay, how lightning actually works. Lightning creates step leaders of opposite polarity of electrical charges. So what you'll find is you get a buildup in the atmosphere of a particular electron, say positive, that will get to a certain level that will be looking for, as in like any magnetic type of theory, positive and negative attract each other. Yeah, you get two magnets, polar, positive and positive push apart, positive and negative pull together. The buildup of electric charge, static in the atmosphere, is doing exactly the same thing. So what you'll find is that it'll be looking, positives up here, it'll be looking for negatives down there. And as that gets bigger, it'll effectively start pulling it together. Okay, and that's when you get things called step leaders, which we'll have a look at in a little bit. Most leader channels to ground are negatively charged, most going downwards are positive. but that's not the rule. And between me and you, it probably doesn't really matter to the effect as to what's actually going to happen when they connect and you get the reverse path that actually creates the big discharge that we all see and know as lightning. Right, I don't think we've got any sound on this at all, but if we have, you'll be able to have a look at some examples. Okay, you can see the intracloud lightning here going side to side, because obviously you still get positives and negatives together in the same situation and they discharge. Lightning always takes the easiest route as well. So you'll see it's not a straight line, it's bouncing around all over the place as it's looking for different changes in the atmosphere. I mean, that's pretty spectacular, but you wouldn't want to be at sea with that going on, really, with a big mast sticking up in the sky or any kind of metal structure on the water. It's it's quite interesting that to see and the power of this. I mean, I actually recently we put a system into a gentleman who's got a Lagoon 50 in Greece, and he said to me afterwards, he said, like, I can't believe it, how much security I feel for me and my family when we get storms, because I just know that I'm protected. He gets his friends come and stay on his boat and stuff like that. And it's really quite amazing. You don't think of that kind of impact when you're actually turning around and doing that kind of thing, but it's quite amazing, really. This is that website I was talking about. Okay, this is just a screenshot showing activity around the world. You can typically see here in our favourite bit, there's bound to be lots of stuff going on up here, up and around here, around Australia. I don't know if this will work, okay, but I will try it and we'll see. Okay, that should. Right, okay. Yeah, go on, you can do that. It's just so you can see there is something going on out there. Going to play havoc with your recording, is it? These figures that are actually in these little circles here show how many strikes have happened within a 3-hour period, and they ramp up, and the colours actually represent how fresh that strike is. Oh, I can't do that. Yeah, go back to the presentation. I'll tell you what we'll do at the end when we finish the presentation. You can just go onto your normal browser and pull it up, and then we can have a quick look then, maybe, if anyone's interested. One more down. There we go.
I've gone to 2 screens.
Oh. Let's abort that, and we can, like I said, when we're finished, if you want to have a quick look at it, we can just go onto the website on your normal browser and have a little look. So this does cause a bit of interest at exhibitions when we have this running, because it does show exactly what's going on. It's really quite interesting.
It's probably a good subject for when really
Yeah, you don't want to be doing that. Right. Stand there and hold this up.
Hi guys, it's Nick here from TMS. Can I just mention something?
Yeah. Yeah.
Anybody know? Can anybody help me? I'm on two screens. I don't know how to get onto one screen. Anybody know? Yeah, I can't remember which one it is. Is it F10? And then you've got to go to duplicate.
That means the same thing on both.
There you are.
Hey, there we go. Right, we're there.
Got that?
That's all right. Right. Okay. See, we've given the class an opportunity to break up now, haven't we? So they're all talking amongst themselves at the back. Right, okay. Right. Little video. Okay. This actually sums up a little bit about the technology, then we can go into a little bit more depth. Okay, a bit of American salesy video. Okay, right then. Have a little look about some of the technologies, okay? We mentioned the Franklin rod. I mean, for 1752, it was something that was, you know, I wouldn't say ahead of its time, because I think people kind of realized that, you know, that sharp things that were sticking in the air were more vulnerable than others. But this was what was recommended at one stage, okay? The static dissipator, which we mentioned before, basically what that does, it kind of supposes is that the charge can leak away from the buildup of static within the atmosphere. We've got a slightly better scenario than that, all right? You'll see here on this little picture, right, slow motion lightning. This is a leader, okay, heading up. So what's basically happening is this is trying to come down, this is trying to come up, and when they actually join, you get the return path strike, which is what happens there, okay, when it gets the full wallop. Okay, now the technology that we're now working with was actually patented by Nikola Tesla in 1916. So it has actually been around for a while. It's not something that we've just kind of made up in the last few years. It has been around for a bit. Now, I think those of you that know a little bit about, you know, the old electrical history and stuff like that, the Tesla, Franklin, Faraday, all of these kind of battles. Tesla was always a little bit innovative in the way that he thought. I mean, alternating current was one of his things. The Tesla coil, again, was one of his ideas, inventions, effectively. Inventions, it was there. He's just kind of discovering it and figuring out how to actually use it. And what at that stage was called a PDCE device. And that was the basis of what our technology now is based on. All right. So you can see here the resemblance. I mean, some of us might remember the old Van de Graaff generator at school where you put there and crank the handle. It looks a little bit like that. But apart from the fact that it's gathering static and charge, about the only similarity. But that whole thing, that whole shape is kind of relevant to what makes it all work. Okay. It's a passive device. Okay. So what it's basically doing is offering permanent protection by balancing and deionizing the effects of the atmospheric phenomena using compensators, which are effectively capacitors inside. This is the land-based version that actually has multiple capacitors here. These are now enclosed. Okay. Now, one of the things I mentioned about certain other similar looking devices that are out there on the market, and the fact that they might have to have surge compressors and stuff like that or whatever. It's the fact that they are fundamentally designed as land-based systems. Now, the company Certec have been protecting nuclear power stations, the American Hurricane Center, Ford, Coca-Cola HQs, about 25 years now. LPG centers, so a lot of stuff have been stadiums, all sorts of bits, right, for a long time. But the problem is they realise that, like I mentioned briefly, is that once you start moving it about, you start to uncover target areas. Now, this has been fixed by the way that they've actually included the multiple compensator technology, which is patented technology, and there's nothing else actually really has that. So, you know, if it isn't that kind of device, even if it has something similar, it's not necessarily working, because lots of things can actually operate in the same technological way, but they're not necessarily operating within the same level of protection. Okay. Okay, this gives me an example of, I can explain exactly how this works for those of you who are interested. All right. Basically, what it's doing, it's looking for what's in the atmosphere. Okay, so it's looking and detecting what's actually going on. Now, what it's detecting is what's going on, obviously nearer to ground. The lightning is effectively coming from way up in the sky, so it's not going to be picking up what's going on up there. But what it is going to be doing, it's going to be looking for the state of the leaders that actually come up. So it's going to be looking at the state of the actual direct atmosphere that's surrounding you. All right. So what it's doing, it's looking at here, and it's saying, right, okay, if I've got a positive here, then I can collect that in the way that you kind of can with rubbing a balloon against your hair and it sticks or whatever. You can present the opposite polarity to that electron, and it will effectively collect. Okay, sticks together on the device, which is fine. Okay, that's that. The problem is then you need to kind of get rid of it, otherwise it's not doing anything at all. Okay, it's just adding negatives, positives, and it's just sitting there. Now, the clever bit is Ohm's law, right? V equals IR, or if you turn it around, I equals V over R. Now, I'll explain it, because to get the V, you need a potential difference. You have a potential difference here within the device. All right, so that potential difference is your voltage. Very small, but it's actually there. So that's your voltage. Okay, your resistive path is going down to your grounding plates, the C. Now, it's going to be very small again, but it doesn't matter. It's still going to be there. So if you've got a voltage and if you've got a resistance, by definition, you have to have a current. Okay, that current, okay, is what actually then acts as a drainage and the facilitating mechanism to actually get rid of the collected electrons that are building up in the atmosphere. Right? Simple as that. Okay, so by actually creating that position to give you a current, to give you the flow, that enables the drainage of the ionization of the atmosphere, which helps stabilize the atmosphere around the vessel, that stops any leaders forming to enable the discharge. Okay, so that's the technology behind this clever bit of kit that Tesla patented in 1916. All right, so I hope that explains how generally it works. Okay, if you want any more information, we can go to town on it later. In terms of the testing and all this kind of stuff that's been done, again, we've got lots and lots of information to back up and show just how effective this technology is at dissipating the static kind of charges and ionization of the atmosphere around. All right, here's a few examples. Generally, what we'd do is when we look at a vessel, we'll get information, we'll fill out a fax form and actually see exactly what it is, and we'll ask for a side elevation of the boat, so we can then actually look at it and work out some calculations based on various things, height, size, and stuff such like that, and decide what size system goes on. Okay, because we've got a smaller one, a gold, which gives a 25-meter radius. Okay, we've then got a platinum, which does a 50-meter radius. Okay, which is typical of your normal leisure cat. Then you've got diamond, which does a 120-meter radius. So this is the type, the types that has just gone on. It goes on to like M5, the sailing super yacht. We've got these. I've just put them onto the Sunreef 140As, another big, nice, swanky, kind of sailing yacht as such. However, you can have multiples, and this is another design that combines diamonds and the gold in the middle there to cover an LPG tanker. All right, so it's not just the little leisure boats we're talking about. I've been involved with Harland and Wolff on some project work that they've been doing or were doing, and hopefully things are back on track again for certain things that we can't really discuss openly, but on this kind of basis, but a little bit more compact. All right, so it's not just the leisure stuff that is protected. Okay, it's everything from NATO craft to these kind of guys, and also Carnival Cruise Liners as well. This is another example. So really, given the price, I don't know, I've done something silly again. Hang on, let me escape out of that. There you go. Given the price and activity of some of these, crew transfer vehicles and sort of vessels and stuff like this, really for the cost of one of these, it really is insignificant in comparison to what they're trying to achieve and what they're trying to maintain and support, and the costs of some of the other bits of kit that they carry on board that they've doubled up on, probably just to, yeah. Some of the be about £5 grand, something like that. Yeah. I mean, a lot of the cost is based on the installation of the grounding system and stuff like that. What we generally look for, I can't remember if I do this in here or not, but typically what you'd have is a 25mm square cable, so that's 10.1mm diameter for AWG type of cable, connected to the CMCE device, which will be at the top of a mast or top of an arch or somewhere prevalent. As long as it can be below whip antennas if they're insulated, that's not a problem. But we'll have that there in a central position, the highest realistic point. That will then go down to a bus bar that will then have the same cable again going from the bus bar at the bottom there to either side of the hull, generally with the same cable to grounding plates that are exterior to the hull. If there's other options, if it's got an exposed metal keel, if there's existing sacrificial alloys in place, if they're large enough, you can work these figures out, because you actually need, I think it's something like, well, it is exactly, it's 926 centimeters squared worth of submerged earthing at any given point. All right, so to actually kind of dissipate the charge properly. Right, so it's not difficult. The thing with these systems is, certainly the CMCE system, is that because the currents are very, very small, because what you're doing is, this is an ionic drainage that's happening here. It's not a charge dissipation. So they are very, very small currents that you're dealing with. But that means that the flow has to be fairly seamless. All right. So they do have to be good. They do have to, it does have to be installed properly, and it does have to be tested. If you actually tested one of these systems, you'd see between 100 to 300 milliamps fluctuation on an AC clamp meter when you actually look at the various chains down the line. So you can actually see that it's working, which is fantastic. And we do actually have monitoring devices as well, which can record all of the information up to the cloud. And also, what you'll notice, an increase in ionic drainage activity shows you that you're getting into stormy waters as well that might not be picked up on the weather radars. Not necessarily. The grounding plates do. You need to get them clean once a year, basically. Okay, or you need to make sure that they are working. You can check it out though. It's very easy to make sure to see if they're working. It's just to put an AC clamp meter on and check to see you've got the fluctuation. Sorry? That'll show you that the actual mechanism, the device is actually draining the atmosphere, because you'll get ionic drainage. You've always got static in the atmosphere anyway. So it'll just, as if it's fluctuating, that means that it is actually draining. But yeah, you should need to really.
All the time, you don't get the radiant build up, so you don't get the leader.
Yeah, Yeah, I mean, yeah, completely. It's a stable, it's a continual stabilization, and it's a passive device. It's not, so it's just a mechanism of actually being able to stabilize the atmosphere around. So that's what it is literally doing. But everything has to be able to work. It's just like, if you've got a buildup of static and you touch your car or whatever, and you get that discharge or whatever it is. So there's ways and means of dealing with it. It's a passive scenario. But
Before, area. The lighting side where it is.
Well, completely, but it's not just necessarily the height; it's the charge status. So by draining the charge around that area effectively, then it means that it's going to be looking in other areas. It's going to be more attractive in other areas. Yeah, completely. So even though it's not a physical height, it's like a magnitude of charge status. Yeah, yeah. Which is why the various sizes of devices can increase that area that you're effectively covering. I think it's like Manila Airport has like 13 devices around the perimeter of the airport to completely cover the airport. So it gives an indication. And we also have devices now that can like have multiple systems that will protect the wind farms, the actual turbines themselves. Okay, which is quite something, but that's kind of a different department. We're not here to talk about that right now. No, completely passive. Hmm? Yeah. Yeah, this is just a grounding bus bar. So literally a cable goes down to an earthing plate, effectively ground separate bus bar that would then be, you can link it into an existing earthing system that's being used by other things. But you've got to remember that if that, certainly if you've got any other AC, you've got generators running on with a grounding, that can then kick back and it can balance, almost reversely balance. So it'll actually stop the device from working. All right, because anything that's going up is going to affect anything that's coming down and could effectively block it. So certainly if it's other passive DC devices on there, it's not a problem. But if you start linking it into other things, this wouldn't affect other things, but other things could affect it. Yeah. But it's always worth checking out what, because it doesn't necessarily mean to say it will. There's certain things, like I say, any AC devices would be a problem, but DC generally would be all right with. Well, it's not that big. I mean, you're talking about 10.1 millimeter diameter, which is when you look at what you would need for like a 12-volt cable, it's kind of not that big. So it's because it doesn't need to carry a hell of a lot of current, but you need to make sure that it carries, the flow is seamless. All right, so that's why you don't go kind of crazy small, but you don't have to go chunky big either. It's finger size. It's not too bad. But it's the kind of size that most people can run without too many problems, and it doesn't introduce a huge amount of weight to the boat if you've got to do it independently as well. Certainly a lot less weight than a old-fashioned system with big straps everywhere. Yeah, it can be positioned at the highest point, excluding the VHF aerials. Okay, this is what we've just been talking about. A simple 25 millimeter squared, so it's 10.1 millimeter diameter-ish cable to the bus bar, and then the cable from the bus bar to external submerged grounding hull plates. Right, to give you some indications, that's what one looks like, a platinum on a masthead of I think that's a Nil 52 trimaran that that's going to be going up on. So that's the typical kind of mounting arrangement here. Okay, that would be a typical grounding bus, your main channel coming down, your main primary conductor from the device through the mast, wherever it might be, or the arch, down to the little simple bus bar that would then go off to each side of the vessel for the grounding plates. Okay, and again, you can see there that on his meter, that's reading 300 milliamps. All right, so that would indicate that is working. One of the things that we do on installation of these with the checks, photograph everything or do a short video to make sure it's working, then we can get it certified, and this can then be handed over to the insurance company or part of backup documentation that you might want to hand to the customer as a pack, like a commissioning pack, because it does show and prove that it is actually working. Yeah, 5 years guarantee. Yeah. 5 years in exceptional circumstances, possibly even up to 10. All right. However, it does have to be checked every year. All right. So you have to make sure that the grounding plate is clean, and you have to make sure that these tests are done. That's all you need to do. They need to be recorded, and they need to be sent back, and then it will be guaranteed for 5 years, or like I said, in exceptional circumstances that can be extended. All right. So yeah. You need to run to a grounding spike. With good thinking, yeah. You need to have that grounding path. But yeah, as long as you connect, if you connect your earthing plates or whatever to a grounding spike. Yeah, it's absolutely fine. It's absolutely fine. You don't need to worry about. That's why the actual surface area is calculated to that degree. I mean, you can actually take it off the single point if you wanted to, and actually have there. You don't need to worry about the size of the plate being submerged, because you're going to be running any tap off of there anywhere straight into a spike, and then that will work fine. Yeah, that's a typical whole plate. Not massive. These sintered plates, I mean, they actually represent. If you have a look at them, they're with the compound of the sintered bronze or whatever it is that they use on the. They're like a spongy material that actually claim to have massive surface areas, and the manufacturers are quite happy with them. So they don't need to be huge, even though when I say 926 centimeters squared, you're thinking about like that. You don't need 2 of them, would be adequate to basically satisfy the boat, and you don't need to have bigger ones going up through the system. All right, one is the same amount of grounding plate submerged is generally adequate, same as the cable size and such like, regardless of the size of the CMC you have on top. Okay, here's a few references. That's NEIL 52 that we saw earlier. We've got, I think, for the 9 that have been produced, the first 5 are actually going out with this system on. Research, National Geographic Research Ship. Okay, so again, it shows that it's not just the fancy pants leisure cats that have these things on. We do supply right the way across. Yeah, up here. Silent yachts. One of the things that we mentioned, the fact that in any area of increased ionic activity, you could potentially get a buildup of increased static within that area. So in effect, some theories suggest that boats that are carrying a heap of solar are actually creating more of a buildup of ionic activity within their little dome of presence than outside of that, which could effectively make them a little bit more of a target, because it works opposite, isn't it? Because basically, yeah, completely. So if you're actually encouraging that to happen with the build-up of solar panels, then you are actually encouraging that whole scenario for a strike. And the crazy thing about this is that these guys are all electric. They've got no, so if they get hit, they're properly stuffed, And there's more and more of these electric power cats now coming out on the market. I mean, there's another one I think pops up. I think I saw on my LinkedIn feed. There's a new Sunreef as well now, Sunreef 80, that's now going all eco solar and such like. And we know with some other foiling tech boats as well that they're looking at alternative power solutions that are now going to be carrying this device going forward. Yeah. No, completely. So it's other bits and pieces as well. We've got lots of the platform supply vessels and such like. We have got a massive reference list of people that go for the technology and get the Certex system installed. And so and M5, that's kind of an obvious one, really. I think, you know, okay. Some of the interesting bits now. This is something that is important to the legislative side of what it is we're actually doing. Okay. Now Lloyd's Register approved. All right, that's recent. Okay. I don't think it hasn't actually formally been announced yet. It's one of those things where we're waiting for the certificate to come through the post, but it's all kind of done and dusted. But we can't actually say, right, yeah, here we go to the press yet, because it's the first of its type. It's the first time that any systems, you know, lightning prevention system has been approved by Lloyd's. We've had the RENA approval now for about 8 months, and this is another one. I'll run this because this is another little video clip.
One of the most prestigious bodies, CMC certification electrical and electronic products and systems, which guarantees devices comply with reliability, availability, safety requirements established by. We are also the first Paraguay to obtain this certification. Certec SRL demonstrates its offering its customers intelligent, effective solution protection against atmospheric.
Okay, so another bit of commercial bits and pieces there, but yeah, the RENA is great, but now with Lloyd's as well, and it's also NATO catalogue numbered as well. All right, so it just goes to show that there are systems available, and as the price is, you know, kind of reflected, you know, there is a way of being able to recommend a solution to customers, whether or not it be commercial, leisure, or whatever, that is effective, and it's not hard to do, and it does give certain element, a massive element of protection, certainly if they're going to be moving the boat somewhere into a high risk area. Okay. Also, the insurance company is getting massively on board with this. By quite a lot of meetings with Pantanius. Pantanius Athens actually offered one of our customers a 10% reduction, and they all by default now negate any excess for lightning strike by moving from the Med over the Caribbean. So all of this stuff plays in hand for what we've got. Okay, so thank you for listening to me waffle on about lightning. I find it a fascinating subject, and yeah. Mm-hmm.
Do you think we have any effectiveness?
I'm guessing they probably do have some. People have been using them for a while now, you know, and whilst I don't think it doesn't stop the risk of lightning, I think it might minimize it. Okay, because you know the theory behind it is sound. It just does it in a more mechanical way than what the CMC. Yeah. I mean, but what it's trying to do is trying to split that discharge up into many different paths. It's not actually, you know, kind of stopping it from happening in the first place. And one of the things that Tesla actually claimed about the whole Franklin situation was that he accused Franklin's theory of being a danger to people and property. That was actually listed as part of the Tesla patent, and a direct accusation as to why, or you know, against like Franklin as to what he'd actually proposed. albeit, you know, it was quite a little way before Tesla, so I think he can be forgiven. But you know, it just goes to show that there's that whole mentality of being like of lightning strike channeling, such as the Franklin rod, and to a degree the static dissipator. You know, you're not on a church. It's not a church tower. We're dealing with vessels that you cannot easily put a big brass copper strip up the side and have it stuck down there and it moves. You know, the conditions change. No, not at all. Now that this technology has been out on buildings for like 28 years now. It's been in the marine industry now for 5 years since they realised how to actually have multi-compensators, field effect compensators in the device to make sure that when things were at heel, they weren't effectively exposed, and it works perfectly. There's not been one single marine strike since this has happened, and I think on land, again, if it's been installed properly and not just been stuck on top of a house somewhere with no actual proper installation and grounding, then it works. I mean, it does actually work. You know, I mean, how you'd actually, I guess, thinking about it in the past, how you would actually, was that Nick chirping up then? Did I hear him?
Yeah, sorry, Steve. So on every asset that's been protected, whether it's land or marine based, they've got a 0 hit to date record.
Yeah. I thought I just said that, but anyway, I mean, you missed that. But I know, it's just like I said, we've had no strikes since it's been installed, certainly on the marine system. So yeah, we're very proud to actually represent this technology, and it's amazing, and it's interesting, and it's science, and it works, and you can understand it. So it's it's good, and I enjoy talking about it. So
there was a boat that got struck in a med last year. It's on YouTube, and the strike came down, and it punched a dozen holes on the side of the hull on the waterline. I don't know if you've ever seen that happen. It's just unbelievable. And you think, well, why wouldn't you spend £5 just to pick them up or something? Yeah.
I mean, there are there's a multitude of scary videos, you know, because I suppose it's a lot more CCTV and stuff like that. Now on marina sides and stuff, they get picked up. But some say that is a possibility with global warming and such like, that there is an increase of lightning. Whether or not it's an increase of reporting of it, now that we have the ability to monitor the electromagnetic pulses and triangulate to see where they are, there's more data available. So, or whether or not it is generally as a result of global warming, I wouldn't be brave enough to actually kind of categorically say that is what, you know, that is happening, you know. But I'm not going to do a Trump and turn around and say it's all nonsense. Karen, hi. Yeah. Very much so. In this whole issue with lithium and thermal runaway and all this business. I mean, that's obviously a completely different subject that's so contentious. I mean, if you have a look at, you know, the amount of fires that you have with lithium and the insurance companies' stance towards lithium batteries on board, but there's no differentiation between a $5,000 Mastervolt, Victron, MG, you know, kind of battery block, right? That if you open the top up, it has as much processing power inside the actual block, you know, for the battery management system as it does actual lithium itself. You compare that to a Happy Dragon lithium cheap deal cell that you can, you know, kind of buy from China on the internet, and they're putting the same. You can buy them for hundreds of dollars. You know, so they're actually having that comparison is not necessarily equal and fair to do that. But in terms of whether or not people are actually going to, you know, kind of say, right, you need to have one of these systems if you're going to do that, I don't know, because I think at the end of the day, the whole danger of thermal runaway and stuff like this is more prevalent if you've got water damage, which is going to do it. If you get it like water impregnating the battery through the case or something like that, or the battery management system doesn't actually control the status of the lithium properly.
It's your particularly professional. If surveys done, you've got most popular and it doesn't.
Yeah, yeah. Hmm.
Yeah,
Yeah, I mean,
no, very creative.
yeah, well, no, and you're right. It's a very, very good point that at the end of the day, as the technology becomes more available, more accessible, people are made more aware of it. What is the judge going to then say if you said, well, actually, you did know about this, you know, and you could have done something or certainly recommended something to yeah. So that's a good point, and I
I
wouldn't.
always wonder, a couple of years ago, go on board a boat, you don't see a CO detector, you recommend it, mention it, it's part of the duty of care. I think Karen and I will talk about that. And I think it is part of it. Yeah, I would, you know, I mean, what the guy chooses to do at the end of the day is up to him. Maybe in a year or two's time, this is the same thing, saying we ought to consider, you know, some lightning protection.
Yeah.
At the end of the day, what the boat owner does is up to them. But in a way, you've sort of covered your back as a surveyor.
You create a new covenant like that.
Oh,
Kind of
loads of them.
Unobvious.
Loads of them, you know. And these things cost what, 20 quid or something for B&Q,
Yeah.
you know, they're dead cheap. So these are a bit more expensive, but it's the same principle.
Yeah, without a doubt, and in terms of the interpretation of Workboat 3 with now, there's a reason why they have turned around and made it a statutory requirement and changed the status of it.
That may well come into the sport and pleasure code.
Yeah.
Does it? It does, yeah. Much better.
But what was the word used in likelihood? That's doing a lot of heavy looking now.
Ambiguity.
It's a huge amount of ambiguity because, like I said, even when you're looking at those charts that we pulled up that weren't actually specified within any, you know, legislative code or kind of annex or appendix or anything like that, that's just independent stuff that we've done. Just shows you the different areas, you know. So, what do you class as an at-risk area?
That's what you find issue is a static disappear.
Or any light. Yeah.
Brought to their attention, not to them whether they want to spend the money to do it, but once don't think because we're not, I'm not an expert in something, you're not an expert in knowing which is the best one, but you've got to attention to tell them that are out there for the purpose of it, and then you leave it to them to go and get it and get it up.
Yeah.
Because otherwise you can't be
No, completely. And all you can, like you say, all you can do is you can recommend and make them aware that technology is available. And, you know, we're always happy to talk to people and explain the differences. I mean, it's yeah, yeah. We're getting a lot more traction. It's almost like over the last few years, more and more people are getting on board with it. They're realizing that, oh, hang on a second, you know, yeah, we're seeing the figures now. Yeah, 5 years down the line and not a single boat that's had this system on has been struck, then that must mean for something. So, yeah, yeah, we are.
Insurable, Karen.
Yeah, I was just gonna ask on the insurance subject, do you have any evidence yet?
It's being intimated. I have had there's definite excess benefits to it, but they're already there. Okay, so if you they will put an excess for lightning strike possibility and potential if you move from the Med to the Caribbean. That's taken away if you've got one of these systems on. So that's already there. One of my customers did say that he had managed to get a 10% reduction in policy from Pantaenus Athens specifically. Now, I think what's actually happening is that these guys now, they're taking down, it's certified, they've got all the paperwork and all the rest of it. Now with all of the Lloyds and the RENA certification, with the commissioning certification as well from Certec, they can take that to the insurance company and actually do on a case-by-case basis, you know, represent. So right, this is what we're doing. And you know, I've had insurance companies phone me up asking for proof that it's been installed and certified on various vessels and such like. So I think it's just a matter of time. You know, do you know Mike? What's his name? From the head of Pantaenus in the UK. He came to my last presentation and he sat right here and he was just like that, listening to it. And he said, "We've got to talk about this afterwards." We've met a couple of times to talk about it. So I think it is one of those things that is gonna come up at some stage. Yeah.
Was mandatory now, to build properties, don't know if mandatory lightning protection for a new build. I know there's surge protection on the circuit incoming. Just a,
Yeah.
you know, I mean, I think I'm going to say on the vessels, yeah, smoke detectors,
Yeah.
carbon monoxide, and I think it's easy to recommend lightning protection.
Yeah, mind you, I mean, surely that's what the difference between the Workboat 2 and the Workboat 3 is on that one, is that it does say you have to have it, but it just leaves a massive ambiguity there in terms of what do you class as being, you know, a at-risk area, or what do you class as being an adequate lightning prevention system, so or protection system. So you've still got those two big areas that are very ambiguous. That's right.
Well done, fellas.
Okay. All done?
Thank you.
Fantastic. Thank you. Cheers. Thank you, Guy.